So, good evening, guys. Very good evening to all of you who are present here. So, here we are with lecture number 12, or I hope this will be the last lecture for geometrical optics. Yeah, 12 lecture बहुत होते हैं बहुत पढ़ लिया geometrical optics. ठीक है. So, I wish to clear all the concept of yours regarding this geometrical optics, and this will be the last session of this geometrical optics. Okay. So let's get started with it. Good evening to all. Okay. At least say good evening, na yaar. I'm addressing you. You will address to me. Hi Shweta, how are you? So here we are with our lecture number 12. Now what is the aim for today? Aim for today is firstly we will recall some concept, okay, that we have learned in the previous lecture. Then silvering of lens we have to do. Huh? Then optical instrument we are deep diving into what kind of optical instrument we are using nowadays and how they works, the ray diagram of them, and the magnification power specifically. In optical instrument, we are focusing on simple microscope, compound microscope, and the telescope. And there is a special type of telescope which is reflecting telescope, also called as Cassegrain. Okay, so that is all we are going to cover today. Got it? Now, first of all, silvering of lenses. Hmm? Silvering of lens क्या है? When we silver the one of the surface of lens and another surface remains as it is. So that lens will behave as the mirror, but with a different focus, with a different power also. Okay. What I'm trying to say you, look, if this is the concave lens you have, this is the concave lens you have, and if you silver one of its surface, then this lens will behave as a mirror because only reflection will take place. There is no passage for light to go in the another medium. Okay, so this will behave as mirror. Another combination will be like that. If you take the plano-convex lens and silver this surface, if you next time you will take plano-convex and you silver this surface, the convex surface. So these are all the example of silvering of lenses. Okay. What is the formula for silvering of lenses? The final focal length here is 1 upon f, capital F is the F equivalent. Okay. Is equals to minus of 2 times of divided by FL, focal length of lens, plus 1 by FM. FM is the focal length of mirror. Here FL is the focal length of lens, and FM is the focal length of mirror. Okay, I hope you got this formula. So we are trying to find out the focal length. Okay, so here is the numerical one example. Find the focal length of the equivalent mirror given in the figure. So here this is the plano convex lens you have. This is the plano convex lens is given. One surface is plane, another surface is curved, convex. Here you will see we have silvered the, this is silvered, okay. So Swati, you haven't replied. Okay, is your doubt resolved or still having the doubt? Tell me, okay, in the chat box. So here the convex part of this lens has been silvered, so there is no refraction can take place, because when light comes, it's totally reflect. Got it? Okay. So this system will behave as the mirror, but it is not a normal mirror. We have to find out the focal length of this, and we have the formula 1 upon f equivalent is equals to minus 2 by fl, focus length of lens, divided by 1 upon fm. This is the focal length of mirror. Now we have to find out the focal length of this lens, and this lens is plano-convex lens. So the radius of curvature of this surface is r, and refractive index of this material is mu. Now we know that 1 upon f is equals to mu minus 1 upon r1 minus 1 upon r2. It is the lens maker formula. Okay. If you do not know the focal length of any kind of combination you have given, like this plano-convex lens, plano-concave lens, just use the lens maker formula to find out the focal length. Okay. So here mu minus 1 is this 1 upon, this surface is surface 1, this surface is surface 2. So this plane surface has a radius of curvature as infinity, minus 1 upon this radius of curvature r here will be measured in this direction because it's a part of this sphere. Got it? So it is minus r because it is measured in the direction of reflected rays. So minus r. So here you are with mu minus 1. 1 upon infinity is 0 plus 1 upon r. So 1 upon f you have as mu minus 1 divided by r. So f of length you will see, you will mention it as FL. FL is equals to r upon mu minus 1. Now what about this mirror? Now the surface which is curved is convex surface is curved. So this will behave as concave mirror. Got it? And you know the relation. The focal length of mirror is half of radius of curvature. Got it? So from here you will see this r is the radius of curvature of this surface only, which is measured in this direction. So this r will be negative. So a negative will appear here. Okay. Now, if you try to calculate this F equivalent, which is equals to minus 2 times of FL. FL is nothing but R upon mu minus 1 plus 1 upon FM. FM क्या है? It is minus R by 2. And for concave lens, it is minus. For concave lens, the focal will be negative. So if you do the calculation of it, it is 1 upon F equivalent is equals to minus 2 times mu minus 1 divided by R minus 2 by R. Take R LCM. The upper part is minus 2 mu plus 2 minus 2. This 2 and 2 will get cancelled out. So here you are with 1 upon F equivalent here is what? It is only minus 2 mu by R. So you will take the reverse of it. It will become R over minus 2 mu. So this is the equivalent focus of this mirror. Got it? So this is how you are going to calculate for it. Okay. Okay. If anyone has any kind of doubt, you can ask right now in the chat box. Now the next question based on the same formula. What formula we have to apply here? The formula is 1 upon F equivalent equals to 1 upon, you can say it, 1 upon F of M minus 2 times F of L length. The length is same here, but It is the curved surfaces come this side. So the radius of curvature will change its sign as positive. Positive radius of curvature. Got it? So we have to find it out that 1 upon FL is mu minus 1, 1 upon R1 minus 1 upon R2. What is the value of R1? The radius of curvature of this surface. This is first, this is second surface. So radius of curvature of this surface will be 1, sorry, R. So it is mu minus 1, 1 upon R, and measured in incident ray direction, so will be positive. Minus 1 upon R2 is the radius of curvature of this plane surface. Plane surface has a radius of curvature infinity. 1 upon infinity is nothing but 0. So 1 upon FL here is mu minus 1 divided by R. FL here is R over mu minus 1. Okay? This is the value of FL. We have calculated. Now FM. FM here is the surface which we have silvered is the plane surface. So it will act as a plane mirror. And I have told you in the earlier classes, the plane mirror has a focal length of infinite. Okay. So focal length of plane mirror is at infinity. Now 1 upon F equivalent here is 1 upon Fm minus 2 times 1 upon FL. 1 upon Fm here is infinity minus 2 times, what is the value of FL? It is mu minus 1 over R, sorry, R over FL की value R over mu minus 1. 1 upon infinity is 0. So 1 upon F equivalent here is minus 2 times mu minus 1 by R. Okay. So from here you can say that this F equivalent here is R open minus 2 times mu minus 1. So that is how you are going to calculate the equivalent focus of a lens when one of the surface is silvered. Okay, got it? You can also remember it. You can also remember in this slide you will focus if this is 1 upon F equivalent, 1 upon F equivalent equals to minus 2 times FL plus 1 upon FM. If I want to try, you want to write this equation in terms of power. So what will be? 1 upon F equivalent is the power equivalent minus 2 times 1 upon FL will become power of lens plus 1 upon FM will become power of mirror. So by that formula also you can also calculate the power of equivalent mirror. Okay. Now the optical instruments. Okay. Optical instrument में what are the uses of it? Firstly, optical instrument are the device that process the light in such a way that the object will appear to be erected and large and much clear. Yeah. But not the every single optical instrument used for the magnification. Some of the optical device also used for capturing the photo, capturing the image also, and some of the uh, optical devices are used for the diminishing the image. Okay, let's take the example of microscope. Microscope, what the microscope is doing? Microscope may we take the blood samples and we study that what a kind of virus in that. Virus is a very very microorganism. Okay, very small. Then you can think. Okay, beyond our thinking. Okay, which is not possible to look with the naked eye like this. Okay, so we use microscope. Microscope is what microscope is doing, microscope is just enhancing that view for us. So it is enlarging the picture. Okay, so microscope is enlarging the picture of the particular object that we have used. Okay, it could be your blood sample, it could be anything, it could be curd that we will observe for the bacteria, positive bacteria, negative bacteria, or we can say it the good bacteria or bad bacteria. Okay, so that is the microscope. The microscope working as the magnifier. It magnifies the object that is present on the glass slab. Okay, I will discuss it in a detailed view, but here just for the information, microscope is doing the enlarging the view, enlarging the picture. Now, what does this telescope do? Telescope is also a device which we can use, which we use to observe the astronomical objects. Okay, so in that, what is it doing? If we are observing the moon, so moon is very large as compared to this. So what is it doing? It is just providing the diminishing image to us. Okay, because to capture the moon is a very big task. Moon is a very big object. So the image that we are getting is the diminishing one. Okay, so telescope is diminishing the image for us. Microscope is enhancing the image for us. Okay, magnifying the image for us. Telescope is diminishing the image for us. Okay, what does camera do? Camera just click the photo, print that photo in the screen. Okay, so that we can use it for later. What is binoculars do? Binoculars is also enhancing the view, enhancing the object size. Okay, so these are the optical instrument that we are interested in. Okay. There is another property of this optical instrument. They just enhance the properties, enhance the characteristics of the image. What kind of characteristic? The details. If you take the example of telescope and you are viewing the moon, if you are observing the moon, so where is the crater? What is the type of crater is there? Okay, so that is that minute information that we can observe from this telescope, not from the simple one, but the advanced version of that NASA is being using. Okay, capturing the capturing an object which is far more distance away from us. It is only possible because of this telescope, na? Okay, so these are the basic feature of this ऑप्टिकल इंस्ट्रूमेंट. ठीक है, जो कैरेक्टरिस्टिक प्रॉपर्टीज हैं उन्हें एनहेंस कर देता है. ठीक है, शार्प कर देता है इमेज को. दैट इज वाई वी आर एबल टू सी द माइक्रो ऑर्गेनिज्म. ओके, what is the size of them, what kind of shape they have taken. Okay, now if you talk about the simple microscope, it is just a lens. You have also used this in your classroom, in your lab experiment. There is a simple it is a kind of structure. I will draw it like this, and this is the lens here. This is the handle that you will use. Okay, so this is the magnifier that we use. Okay, got it? So this is called as the simple microscope. A simple microscope is nothing but a magnifier. Okay, and it is a what types of lens we have used in this? It is converging lens. Converging lens. Got it? It is also called as convex lens. Convex lens. So what type of lens we are using in this simple microscope is the converging lens. Okay. What is happening? This is the object we trying to observe. Okay. We put this lens near this object. So this is a ray, incident ray. This ray is passing through the optical center, so it will not deviate from its path. Okay. and this is deviated from its path. This is the original path of it. This will be the original path of it, and it is just deviate from its path. But these rays after refraction never going to meet because they are not parallel. If these are not parallel, then after refraction they are never going to meet. Never going to meet. Okay. So if we try to extend these rays, if we try to extend these rays would appear us to be meeting at some point far distance away. So this is the enhanced picture of this object. This is the virtual image because there is no such kind of object present here. These rays appears to be coming from this point. Okay. So this is the virtual image, and it is erect also. Got it? And it is magnifying. So a simple microscope, what does it do? It uses a converging lens, okay, of short focal length. Short focal length का मतलब क्या? कि if the focal length is short, then the power of lens will be high because power of lens is inversely proportional to focus. So if focus increases, power of lens decreases. In focus decreases, power of lens increases. I will write it as here. If focus increase, then power decrease. So if this lens has a short focus, so it will try to, if this is a lens, this has short focus, so it will try to converge it near to it, okay, rather than converging it some point here. So this will give you a picture very large than your capacity, okay. So that is why we are using a lens here which has short focal length. Short focal length. Okay, got it? I hope you are getting this. Just a second. Huh? Yeah. So here in the simple microscope, we use a converging lens. The object is placed on the principal axis. The virtual magnified image we get, okay, by this simple microscope. So here the idea is to form a erect, magnified and virtual image of the object at a distance which is comfortable for eye. Now what is the comfortable distance for eye? I will discuss it here. So formula for magnification for simple microscope is M is equals to capital D into 1 upon F plus 1 upon V, where capital T is the comfortable distance. Comfortable distance for eye, okay, which is nearly equals to 25 centimeter. So just note it down. This is the nearest, or this is the distance which is very comfortable for eye to view. Okay. Now, in case first, we are discussing if final image is at D, means जो final image बनी है, it will form that D, means at 25 distance centimeter. So here V you would put it as capital D. V is the distance of image. Okay, so in first case, if final image forms at D, means V is equals to D. So put this V equals to D in this equation. So M here is capital D, 1 upon F plus 1 upon capital D. Multiply this D inside. So you will have 1 plus capital D by F. M1. For this case 1 I am discussing about. Okay. Now case 2. If final image is at infinity, means V is equals to infinity. So what do you have? M is equals to D times 1 upon F plus 1 upon infinity. So what do you have? D by F. Only 1 upon infinity becomes 0. So you will write it as M is equals to capital D by F. This is M2 for case number 2. So all the points should be noted down. Okay. Now formula for magnification हो गया. This is M is equals to D into 1 upon F plus 1 upon V, where V is the distance of image, capital D is the comfortable distance for eye, which is nearly equals to 25 centimeter. Okay. Now compound microscope, and this is one in which the question has been asked. ऐसा नहीं है कि पिछले वाले से नहीं पूछा जाएगा. From simple microscope there is a tendency, there is also some chances to be question to be asked. Okay. Compound microscope. So compound microscope is, you have seen, this is the picture of compound microscope. Here we have used two lenses in this. One is called the eyepiece and one is called the objective. So here multiple objective lens we have used. It is not a compound simple type of compound microscope. It is the advanced version of it. Okay. This is the specimen. Here we put that glass slab on which the object that is to be studied is placed. Okay. Here from where you have seen this portion, it is for the light to become, so that you will see a brighter picture. Okay. And this is the aperture diaphragm. This is also. Okay. So in this is the advanced version of simple microscope. It has two lenses, one of the eyepiece and another is the objective. Okay. The lens nearer to the object, simple सी बात है, if lens present near the object, so this will termed as objective lens. The lens present near the object is termed as objective lens, and the lens near the viewer who is viewing this, who is seeing that image, is called the eyepiece. Okay. So as in the definition also, the lens nearest the object is called the objective, which forms a real, inverted and magnifying image of the object. This serves as the virtual object for the second lens and the eyepiece. The second lens here is, this is eyepiece, which is known for the observation. Okay. Eyepiece. Got it? Which function essentially like a magnifier. So it producing a very large image of the object. How it is forming, how the rays are passing, I will discuss in the next slide. Okay. So here from this slide, you have to keep few things in mind, that in compound microscope, although it is written here is simple, it is not simple, it is compound. Okay. So in compound microscope, few things that you have to kept in your mind. First is that it is made up of two lenses. Yeah. One of them is objective, another is eyepiece. Now, which lens is to be said objective? Which is placed nearest to the object that we are studying is called as the objective lens, and one of the lens in which we are viewing the view, we are seeing that object, is termed as the eyepiece. Okay. Got it? The objective lens forms a real, inverted and enlarged picture. That picture serves as the virtual object for eyepiece, and it enhances it. It enhances the magnifying power of it. So image will be more magnifying. Okay. Now, in this slide, I'm going to discuss how this ray diagram has been. So ray diagram for compound microscope. Okay. Now this is the principal axis first of all. Okay. I will have make all the diagram here in the animated form so that you will understand it better. Okay. This is the principal axis. Now this is the lens, one of the lens. This is second lens. In this also, the eyepiece, the lens of eyepiece is smaller. Okay. Here the image, here the object is placed. This is object. So one of the rays is going parallel to principal axis. After reflection, it is bending, cutting at the focus, okay, and moving it in this direction and meeting this lens at this point. Got it? Now, and after refraction, because this lens is also going to refract this, it is also trying to bend this. So this is going in this direction. Okay. Now there is another ray which is passing through the optical center. You just assume that it is passing through the optical center of this lens. So it is moving without deviation and meeting this ray at this point. So there is an image formed over here. Okay. Also, after refraction, it will move in this direction by this lens. Okay. Here, the size of eyepiece, I must write size of eyepiece, eyepiece is larger than the objective. Objective. Now you guys tell me, what is the name of this lens? Although it is converging and convex, but what is the name? It is objective or eyepiece? Tell me. Because this lens is placed nearest to the object, so it is said to be objective. Okay, got it? And the another one is eyepiece. Eyepiece is larger than the objective. Okay. Now after that, from this image, this is a ray passing through the optical center of this eyepiece, so going without deviation. Now these rays are not parallel, not parallel, so they will never going to meet in this side. Okay. Although you will see this is the image that has been formed by this objective lens. Objective lens has formed this image. This image work as the virtual object for this virtual object. Okay. There is no object present here, only the image is. But for this lens, it will behave as the virtual object. If I try to draw this, if I extend these rays backside like this, and this, so they will appear to meet at this point. Means there is a larger picture that we are going. It is the final image. Final image. Okay. So you will see that this image is virtual. It is virtual, inverted, उल्टी है ये, inverted and magnified. Magnified. Okay. So again, if I am going to discuss this, what is happening? So this is the principal axis and these are the lenses. This is the objective lens. This is eyepiece. Now a object is placed on the principal axis. A ray is going parallel to it. Then after reflection, it is going in this direction. Okay. Refraction. Now again, it has the refraction from this lens and move in this direction. The another ray, which is coming to the optical center, moves without deviation and it cuts the point at this point. So this is the image has been formed. This image is real and inverted. So it will behave as the virtual object for this eyepiece. Okay. Now, if you try to draw, because these rays are not parallel to each other, so this will not meet in this side. Got it? These rays will not appear to meet in this side. So they will appear to meet in the back side if I extend this. Got it? So here a very big image has been formed, very magnified image formed. This is the final image formed by this compound microscope. Okay. This is virtual, inverted, and magnified. Okay. Now, you both of many of you will think कि ये तो उल्टी बनी है लेकिन माइक्रोस्कोप में तो हमें सब कुछ सीधा दिखता है because on that microscope there is a plane mirror is also used which invert this again. ठीक है, तो उल्टी को सीधी कर देता है. ठीक है, so we use a mirror there. Now magnification in compound microscope, the formula for magnification is this: m is equals to VO upon UO D upon VE plus D upon VO. VO here is nothing but distance of image from O means objective lens, and UO is distance of image from objective, distance of object, not image, object from objective lens. This VE is distance of image from E means eyepiece. Eyepiece. Okay. And this VO is again, VO is same. Okay. And D here is approximately equals to 25 centimeter, which is the comfortable distance for viewing profile. Now in the first case, what you will have it is D upon VO. Okay, one mistake is there. This is not VO, this is F of E. So the new formula here is M is equals to VO upon UO D upon VE plus D upon FE. So not this formula where FE is the focal length of eyepiece. Okay. Okay. So not this formula. Then we are going to discuss the case number 1. If final image is at D. Okay. Final image कहाँ पे बन रही थी? This point. Okay. Got it? Now. This is VO. You will see. This is the image. Distance from the objective lens is VO. Okay. This is VE. Distance of image from eyepiece. This is nothing but UO. ठीक है, got it. Now, if the final image is at D, so this VE become capital D. So if I put this here, what does the formula will look like? It is M is equals to VO over UO. D upon D is 1 plus D upon F. Okay. Now, in the second formula, if the final image is at infinity, then how we are going to proceed? If final image forms at infinity, then this VE will become 0, because V is the distance of final image from the eyepiece, and we are viewing the view from the eyepiece. So this V would become infinite. Okay. So we only left with M is equals to VO over UO into this D by V will become 0, because V here is infinite. So it is 0 plus D upon FE. So we can write it here. M is equals to VO over UO D over FE. This is the formula for magnification in second case. Okay. I hope you are clear with this. If you have any kind of doubt, you can ask in the chat box. You can write the thing in the chat box. Okay. So these formula are very important. You must keep these formula in your mind. Okay. Try to write these formula on a blank sheet and stick on the wall in front of you. And whenever you will sit for the study, you will have an eye for this paper and you will remember this formula forever. Got it? So there is no extra effort is made by you to remember these formulas. Okay. And suppose if you got one question from this optical instrument and you know the formula, then you are able to, because it's very simple question has been asked in JEE Mains. That's the formula based question. Okay. And if you do not know the formula, then it is a very big mistake, na? Okay. Because one question enhance your rank in thousands, will throw you in front of the thousands of aspirant. Okay. If your rank getting 1200, then after solving that particular question which is right, it will become 200. Okay. So that is the difference of only one question. So each and every question is very important in JEE Mains. Okay. So try to learn these formula. Okay. Now, this is our telescope. Okay. Telescope we use to observe the astronomical object like the meteoroid, asteroid, planets, moons. Okay. This is the object that has told us that Jupiter planet has more than 100, uh, more than 100 moons. So this is why we are going. Okay. So telescope, tele is a word which is used for distant object. Okay, that is why it is known as telescope. It is similar to microscope, but there is a very big difference. There's a difference in the length of the size of the lenses that we have used in this. Okay, so telescope is used to provide the angular magnification of distant object. I have discussed it in the very earlier of when I'm discussing the optical instrument. I have told you that moon is very big to capture in one photo. Okay. So what does this telescope do? It create a diminishing image of it. Firstly, it will a diminishing image, but when we are observing it, it magnifies that diminishing image for us for the better understanding. Okay. The difference between telescope and microscope is very simple. Here, the size of the eyepiece is small and the size of the objective is large. Why it is so? because rays are coming from a very distant object. So we need more rays for better magnification, for better picture quality. Okay. The number of rays, how many number of rays will come, it will increase the quality of the picture that we are getting. Okay. So we kept the size of objective lens is large, but the size of this optical, this eyepiece will be kept as short. Okay. It is not as much short ki you are not also view the object, because it is only happening for us now. Okay. So this eyepiece here is has low aperture, and the objective lens has a large focal length and much larger aperture than eyepiece. This is the beautiful picture of this telescope. This is telescope. You will see this lens. Here it is a lens, which is the objective lens. Objective lens. Here is the eyepiece. Eyepiece. This is somehow tilted, you will see. Hai? So here we have used, in this projection, we have used a mirror to invert the image. Okay. Now, if I talk about the ray diagram for telescope, again we have taken a principal axis. This is our, the bigger lens is what? Objective lens. And it is also nearer to the object. So it is objective lens. The ray is coming from where distance. After getting refracted, it meets this lens here. And from this lens, it is also getting refracted. So this ray is coming from this point to this point. Again, a ray is coming to its optical center, we have assumed, and these are parallel rays. Okay. Now, this ray, after, without any deviation, it will move. And after refraction from this lens, this is the eyepiece. Okay. This is the eyepiece. So after refraction, it moves in this direction. But these rays are not parallel. So it will appear us to meet from this point somehow here. So this and this. So they will appear to meet at this point, means image will be formed here. So this is the final image. Also, there is also an image here, which is real image, and it acts as a virtual object for eyepiece. Okay. And this is final image, which is virtual and magnified. Got it? So this is it. Now the formula for this is very simple. It is m is equals to minus f of o. Fo here is focal length of objective lens. I am writing it only objective. Fe is focal length of eyepiece. Okay. And V is the distance of image from the eyepiece. Okay. In the case 1, if an image is at D, means the final image bani, it forms at D. So put VE is equals to D here. So M is equals to minus FO 1 upon FE plus 1 upon D. Got it? And if image is at infinity, then VE is equals to infinity. So m here is nothing but minus FO into 1 upon Fe plus 1 upon infinity, which results in m is equals to minus FO to 1 upon Fe 0, which is minus FO over Fe. This is the magnification in second case when image formed at infinity. Got it? Now, the reflecting telescope. This is the last telescope that we are last optical instrument. Okay. And the last topic of this lecture. So the reflecting telescope, it is also named as Cassegrain. So how it is different from the other? So in this, we have used mirror. So this is a convex mirror we have used. It is convex mirror. Okay. So a ray is coming this side after reflecting. These are the objective mirror. Objective mirror. These surfaces from here to here. Objective mirror. This is also behaves as objective mirror. This is eyepiece. Okay. It is eyepiece. Got it? So a ray is coming from distant object. These are the rays, parallel rays coming from a distant object. After reflection from this point, it moves in this direction. It moves in this direction. Again, it will reflect it in this direction and in this. So these appear to meet here. So very sharp image of the distant object will be formed at eyepiece. Okay. So it is very simple to make, but for the simple purpose. Okay. Advantage of it is no chromatic aberration. The chromatic aberration is like if this is a lens, okay, violet color is coming to this is violet color and this is red color. So it has a refractive index mu. So mu will change the deviation of violet color and red color. Okay. Violet color has greater deviation than red color. So this difference between the object, because these rays are coming from the object na, so this difference is termed as chromatic aberration. Okay. Aberration. Okay. So by using this reflecting telescope, which is also termed as Cassegrain, it reduces the chromatic aberration. And there is a very less mechanical support that we need. If you will see this telescope, there's a lot of mechanical support that we have used. We have used a tripod, and for the bigger purpose, it mechanical support enhances it, indirectly increasing the cost of making it. Okay. But in this, you will see there is a simple, we have used the mirrors and one lens only. So less mechanical support is required. So these are some properties of it. We have done with that. No chromatic aberration, less mechanical support. Okay, I hope you got this. So this is it from my side. If you have any kind of doubt, you can ask. Otherwise, the lecture is over. Thank you so much for being attentive and take care of yourself. Okay.